Alright, we've got a few more examples I'd like to take a look at in this video. First up, we've got an oil tanker is leaking oil in a radius around the ship. So here is my oil tanker, and it is leaking oil in a radius around a ship. That's no good. A helicopter monitoring the ship measures the radius of the spill to be increasing at 0.32 feet per minute. So actually, let's just stop right there. I see increasing, I see 0.32 feet per minute, so we're talking about a derivative. The derivative of what? The derivative of the radius of the spill. So in other words, they're telling me that dr dt, it's increasing, so it must be positive. Dr dt must be a positive 0.32 feet per minute. Find the rate at which the area of the spill is growing. So I'm actually just going to stop right there. The rate at which the area of the spill is growing. So I want to know the rate of change of the area, dA, with respect to time over dt. This is going to be what I'm looking for. Let's see. When the radius was 500 feet. So the radius r is currently 500 feet. And this is everything that the problem gives me. So it looks like I have a few variables here. I've got dr dt, or just r there. Whoops. I've got a, so for the area of the oil spill. So here I would be looking at the area of this circle. And then r, again, the radius, that's just the radius of our circular spill here. So I need a relationship between area A and radius r. And I'm thinking about area formula of a circle. The area of a circle, this would be a good one to know, would be A equals pi r squared. There's a relationship, an equation that relates A and r. So I have my equation that relates A and r. Let's go ahead and take the derivative of it. So I'm going to take the derivative of both sides with respect to t. On the left-hand side, derivative of A with respect to t, well, that's just going to be 1 times dA over dt for my chain rule. Can't forget about that. Equals, over here, be careful. Some of us might look at that pi and think that we need to use a product rule, but remember that pi is just a constant multiple. It's a long, irrational constant multiple, but it is just a constant multiple. So I will multiply by 2, so I will have 2 times pi times r, that's our derivative of pi r squared, times the derivative of r with respect to t. Because we're using implicit differentiation, we need to remember our chain rule, multiplying by the derivative of r with respect to time t. So let's see, dA dt, this is what I'm looking for. 2 pi r, I know that r is 500, and dr over dt, we know that that is 0.32, so it actually looks like I have everything I need. Let's go ahead and plug in the information that we have. So dA over dt is equal to 2 times pi times r, we said that was 500, times dr over dt, we said that was 0.32, and after that we're just simplifying that right-hand side. So 2 times 500, that would give me 1,000, times 0.32, this is really 320 pi. Or if you wanted to give a decimal approximation here, let me just double check. I believe 320 pi, just over 1,000. Yes, 1,005.31. And again, I'd want to give a unit on here. So what's the unit on area? Be careful, because you might look at this and say, well, my unit on area is feet, because that was the unit on dr dt. But remember, area has a different unit than, say, radius does. We measure area in square feet. So we would say 1,005.31 square feet, or feet squared, per, what is my unit of time now? Well, we said per minute, that is my unit of time. That part has not changed. So we have either 320 pi feet squared per minute or 1005.31 feet squared per minute, just depending on whether you want an exact answer or a decimal approximation. Let's look at one more in this video. Here we have two cars that leave the same city at the same time. One car travels north at 55 miles per hour, and the other travels west at 60 miles per hour. So, okay, let's see. Here's our city. One car, it says, travels north. I'm going to call this side A, just to give it a name here. Now, I don't know what A is, but it says we're driving north at 55 miles per hour. Again, keep an eye out for rates, because those are what tell you not the side lengths of your shape, but those tell you your derivative. So that would be dA over dt is equal to 55 miles per hour. The other travels west. The other one goes in this direction at 60 miles per hour. Again, I see miles per hour. That's a unit. I'm going to say, how about we call this side B? B is, I don't know what B is right now, but I know that dB over dt, the rate of change is 60 miles per hour. So dB over dt is 60. We want to know how fast will the distance between them be changing after 2 hours. The distance between them, that is this distance right here. Look at this. I've created another right triangle. I have A, I have B. I want to talk about this side over here, that hypotenuse. How about I call that C? And let's see, I would like to know how fast will the distance between them be changing. So what is dC over dt here? That's what I'm trying to find out. So this perhaps is a little bit weird, because we don't know what A is, we don't know what B is, we don't know what C is. But we can find this information out because we want to know how fast the distance between them is changing after 2 hours. So we know that they've been driving for 2 hours. So one's going north at 55 miles per hour for 2 hours. So if I take that rate, 55 miles per hour times 2, I would have it traveled 110 miles. Similarly for B, that's traveling at 60 miles per hour, again for 2 hours. So 60 miles an hour for 2 hours, that would give me 120 miles. If I have A and I have B, that means I can solve for C using the Pythagorean theorem. So I know I have A squared, that's 110 squared, plus B squared, that would be 120 squared, equals C squared. That's the missing side. That's what I'm trying to find. So let's see. 110, I should have 121, 0. Let's see, 12,100 plus here 14,400. Let me just double check my math. Yes, that looks good. Equals C squared. Take these two, add them together. So let's see, I have 26,500 for my C squared. So C is equal to square root of 26,500. I don't think this works out to be a particularly nice number. It does not. How about we go ahead and call C roughly 162.79 if we round it to 2 decimal places. So C is 162.79. So let's kind of take stock of what we have here. We have A, we have dA over dt, we have B, we have dB over dt, we have C. I don't have dC over dt, but that's what I'm looking for, so that's okay. So let's go ahead and let's look at our equation that relates them. And again, we've already used it once so far. Just the Pythagorean theorem works just fine here. So a squared plus b squared equals c squared. I'm going to take the derivative with respect to time. So derivative of a squared, I'll have 2a, but I'm using the chain rule, I'm using implicit differentiation. I need to multiply by dA over dt. Plus the derivative of b squared, well, that's going to be 2b. Again, I'm using chain rule, implicit differentiation. I'll multiply by db over dt. Equals derivative of c squared. Well, derivative of c squared, that would be 2c. Again, chain rule, implicit differentiation, need to multiply by dc over dt. And now I just need to take the information that I have up here in my drawing and plug it into this derivative. So let's see, 2 times a, that is 110, times dA over dt, that is 55, plus 2 times b, that's 120, times dB over dt, that's 60, equals 2 times c, that's 162.79, dc dt, I don't know, that's my variable, that's what I would like to solve for. So let's see, I should end up with 12,100 once again, but again, I just want to double check my mental math here. Yep, 12,100 plus this will be 14,400 is equal to 2 times 162.79 gives me 325.58. We'll finish up over here. So let's see, I've got 26,500 equals 325.58. And actually, if you'll notice, I forgot to bring down the dc dt to the next step. So let me fix that over here. This should be dc dt. I should have dc dt here. And then I'll just need to divide by this 325.58 on each side of my equation. So let's see, if I do this division very quickly, I should end up with, dc over dt is about 81.39. So okay, let's find a unit and then just check the sign. Let's see if it makes sense for our problem. What are the units on C? C measures the distance between those. We were talking about miles, so 81.39 miles per unit of time. What's my unit of time? Per hour. So my unit of time in this case is hours. So 81.39 miles per hour. And let's see, if one car is going north, the other car is going west, does it make sense that I have a positive rate of change here? So let's see what's happening to C. If I move those cars a little bit further, the red line that I've just drawn right here seems to be longer than that blue dashed line right there. So yes, it seems to make sense that we have a positive rate of change because side C is getting longer as time progresses. So we have our related rates. Answer, we have dc dt is 81.39 miles per hour.